Hey everyone, we're going to continue our discussion on quadratic functions. And in 2.2a, we looked at quadratic functions that were set up into that graphing form or that vertex form. And today we're just going to look at quadratics that are in the standard form and then how to pretty much do the exact same stuff that we did in 2.2a. We want to be able to find the vertex, knowing if it's opening up or down, finding the Y-intercept, the X-intercept, that axis of symmetry, if it has a maximum and a minimum, the domain and the range. Okay, so now we're looking at our functions in that standard form. So if we had f of x equals ax squared plus bx plus c, that's when we're in our standard form. Where if we remember real quick, our vertex or that graphing form, we would have had f of x equals ax minus h squared plus k, right? This was our vertex, or I like calling it our graphing form, okay? And today we're looking at this is what we call standard form. And they're both quadratics because they're raised to the second degree. It's just different representations, kind of like if you go back to when we were doing linear, you could have point slope, slope intercept. There's different forms. You could even have it in standard form. There's different forms or different ways of writing equations, right? So different ways of writing the function. So the same thing happens with quadratics. There's more than one way to write the equation. So we focused on this in 2.2a. So today we're going to kind of focus on in the standard form and how to kind of pull some of that information out. So if we go through kind of our list of things that we needed to do, the one thing we needed to do was find the vertex, right? So the vertex, if it's in standard form, there's a cute little way to figure out the vertex. The vertex is that HK, or that other point is still technically an XY coordinate point, right? So to find the X coordinate, or our H of our vertex, we do negative b over 2a. And then this looks a little complicated, but you're taking whatever that answer is and you're plugging it back into the function. You're plugging it back into f of x. So you're plugging in for f of negative b over 2a. What this is saying is you figure out what your x is, right? And then this is f, why do I need to do that? This is f of that new x. So you're just taking that x and you're plugging it back in to get the y coordinate, right? Or with it being the vertex, technically it's our HK. And then when it comes to opening up and down x and y intercepts, we'll just kind of go through those on a case-by-case basis. So let's try a problem. I'm going to try and fit it on the screen. So let's say they give us f of x equals, I'm going to spice it up a little bit and go with a negative x squared minus 2x plus 1. So if we want to, we can start off by writing out our a, b, and c. So a equals negative 1, right? Because that's this here would be our a. So our a is negative 1. Our b is negative 2. Our b is the number in front of our x term. And our c is going to be 1, right? So we're just going to kind of go through all of the different little steps, same thing that we did on 2.2.1. So the first one is finding the vertex. So to find the vertex, we have our little formula up there. So negative b over 2a. So negative b, our b is negative 2, all over 2 times a, which is negative 1. Right. So we're just going to kind of work on simplifying that, right? I'm just going to do, I have a negative and a negative, so I'm just going to make that a 2, but then I have 2 times negative 1 on the bottom, which is still going to give me a negative 1. Oh, my bad, sorry, negative 2. 2 times negative 1 is negative 2. Then I'm just going to keep simplifying this down. Negative 2 over 2 is the same thing as negative 1, right? So now when I go to make my graph, if I make a little graph over here, right? 1, 2, 3, 1, 2, 3. We know that now our x coordinate, or our h, is going to be negative 1. So then now we just need to figure out what our y is. So in order to figure out our y, we're going to take that negative 1 and we're going to plug it into our original function. So my original function's written in blue. So we have a negative, and then our x was negative 1 squared minus 2 times our x, which was negative 1 plus 1, right? And just keep simplifying it. So I'm going to keep that negative 1 there, so I know that that is my h coordinate. And then now I can just work on this part. Negative 1 squared is 1, but I have a negative out front, so that's going to actually keep that negative 1. Negative 2 times negative 1 is going to make that a positive 2 plus 1. Right. Do the math. Negative 1 plus 2 plus 1 is going to give us 2. So now we know that our vertex on our graph is going to be at negative 1, 2. So negative 1, 2. So we know that our vertex is right there. We can determine if this is going to open up. Is it going to open up or is it going to open down? Our A is a negative, so we know that it's going to open down. So since it's going to open down, it's going to cross the x-axis. So we need to figure out where it's going to cross the x-axis. And it also crosses the y-axis, so we can figure out where it's going to cross the y-axis. So I'm just going to add another little bullet right here. Let's go back to white, right? So we know that this was our vertex. We know that it opens down, right? And then now we can do our x-intercept and our y-intercept. I think the easiest one on this one is going to be to find our y-intercept. Our y-intercept is always when x equals 0, because that's when we are crossing the y-axis. So I'm going to look back at my original equation, and if I plug in a 0 for x, this becomes 0, this becomes 0, and my c, whatever my c is, that's always going to tell me what my y-intercept is, because my y-intercept is when x is 0, so these are going to go away, so I'm going to have my 1. So my y-intercept is at positive 1, right? So on my graph, I know that I'm going to cross at when y equals 1. So now we need to find our x-intercept, and we know our x-intercept is when y equals 0. So I'm going to go back to my original equation, and I'm going to plug in 0 in for y so I can solve it for x. So now I have 0 equals negative x squared minus 2x plus 1. I'm just going to use the quadratic formula to solve it for x. So I'm going to have what? X equals negative b, so 2, plus or minus the square root of b squared, 4, minus 4 times a times c, which is going to give me a negative 4, which is ultimately going to give me a positive 4, right? Because a negative minus the 4 is going to give me a positive 4, all over 2a, negative 2. So we have, simplifying it, 2 plus or minus the square root of 8 over negative 2. And if you want, I'm just going to pull the negative out front, so it's not just in my denominator. I like it in my numerator. It's in wherever you'd like it, right? And then on this one, like, granted, we could go through and we could simplify the square root of 8, right? That's going to simplify down into 2 times the square root of 2. But I'm looking for where this crosses the x and y axes. So I actually want to know the point where it is. So not all of us are like, if I were 2 times the square root of 2, where is that? I'm going to still have to put it into my calculator in order to figure out what that value is. So if I'm looking for a point on my graph, ooh, I didn't want to do that. When I'm looking for a point on my graph, writing it this way doesn't help me. I have no idea where that is. So I'm going to put that into my calculator and I'm going to figure out those values. So when I put this into the calculator, when I do -2 plus the square root of 8 all divided by 2, you might want to throw that into parentheses and then divide it by 2 just to make sure that your calculator is doing the operations correctly the way that you want them to be done. I'm going to get approximately 0.4, and then I have to do it again in my calculator. -2 minus the square root of 8, I'm going to have all that in parentheses, divide that by 2, and I am going to get approximately -2.4. So I guess I could have made my graph a little bit bigger. Might probably show up a little bit better. But so I know then that I am going to cross the x-axis at 0.4, so not quite half. Whoops. And at -2.4, so -2.4, so right about there, right? And then now I can make a fairly accurate graph of my quadratic, right? And then the only thing, maximums and minimums. So on this one, since it is opening down, I'm going to go up until I get to a point, and then I'm going to come down. So it's going to have a maximum, and here's my maximum value. So my maximum value, it's always going to be that y value of your vertex, right? So we have we got x, we got our x-intercept, we got our y-intercept. This one has a maximum, and it's a maximum value of a +2, right? So now we need to find our domain. Our domain is our x values. When it comes to our quadratic, we don't have any limitations on our x, so we know that our domain is going to go from -infinity, gotta love those infinity symbols, right? -infinity to +infinity. And our range is our y values. So my smallest y value that I could possibly end up getting is going to be way down here at -infinity. And then my y values, I'm going to be able to use all of my y values until I get to y is 2. And I know that I can't get above 2, and I know that I can be 2, I just can't go above 2, so I'm going to have a closed bracket on that one. I know there's quite a bit of stuff on the page. We kind of ran around in little circles a little bit getting everything on there, but look for those bullets. Those bullets are all of the items that we need to be able to find. So what is it? The vertex, that it opens down. We found our x-intercept, we found our y-intercept, we found our domain, we found our range, and we found that it had a maximum value, right? So what is that? 1, 2, 3, 4, 5, 6, 7? 7 things that we can find.